Welcome to the Vision Campus. Today we are talking about a topic that is often underestimated in computer vision systems, although it plays a central role and has a major influence on the results of image processing. Lighting is of great importance for the success of your vision system. Ideally, the lighting should highlight the features you are looking for in a repeatable manner and should be precisely synchronized with the camera and automation system. There's a whole range of factors related to light. Let's take a closer look. The first factor is the right type of lighting. The most commonly used types are LED, bar, ring or backlighting. Bar lighting creates a light strip on the target object for uniform illumination of the entire localized area. Different bar lights can be combined to cover the target object from all directions. Ring light is a circle of bright, intensive lighting for shadow-free illumination and good image contrast. Due to its versatility, the ring light is suitable for a wide range of applications. Backlighting projects the light evenly from behind, highlighting the outline of the target object. This type of lighting is used to detect the presence or absence of holes or gaps, to measure or check the outline of the target, and to improve the visibility of cracks or bubbles on bright or transparent target parts. With these types of lighting, different lighting techniques can now be realized. With a direct front light illumination technique, some surfaces appear partly bright but overexposed and partly dark due to total reflection. In order to avoid this, the diffuse light softly illuminates the surface with a homogeneous incident light. Diffuse light is therefore useful for inspecting specular, polished, shiny or metallic objects. In order to keep costs low, diffuse lighting techniques can be implemented with a bar or ring light, for example. Dark field illumination brings light onto the target object at a flat angle. Scratches, edges, marks or nicks on surfaces reflect the light back to the camera, so that these appear bright while the rest of the surface is dark. This effect can be achieved very well with a bar light. The backlighting technique is useful for detecting the presence or absence of holes or gaps, for measuring or checking the outline shape of the target object, and for improving the visibility of cracks, bubbles or scratches on transparent target parts. Therefore, the light is projected evenly from behind the target object, emphasizing its outline. With this type of illumination, it should be noted that surface details are lost. In addition to the types of lighting and techniques, the wavelength of your lighting has an enormous impact on your results. Visible light is usually defined as having wavelength in the range of 400 to 700 nanometers. When any wavelength of light interacts with an object, it can be reflected, absorbed, scattered, or transmitted. Especially the effects of absorption and reflectance is used in machine vision to detect or distinguish specific objects. Imagine an inspection task requiring red candies to be separated from blue ones. To save costs, the trick is to use red light and monochrome cameras. The red candies reflect the red light completely and thus appear to be very light, while the blue ones primarily absorb the light and appear as dark. The light source and its wavelength is thus a decisive component of a vision system. Last but not least, it is of great importance that the lighting is precisely controlled. In many vision systems, the camera, the flash controller, the light and the machine control are from different manufacturers. This makes exact synchronization of these components challenging, as it can lead to inaccuracies in transferring information. In order to get a constant image quality suitable to your requirements and to extend the service life of the LEDs, the camera and the flash should trigger at exactly the same time, down to the microsecond. A perfectly coordinated vision system from a single source can take care of this. In conclusion, Lighting plays a central role in an image processing system. Insufficient lighting of the target object can lead to a loss of information and productivity. It is complex to find the right type of light, the right technique, as well as the right wavelength, respectively color, for your requirements. However, it's definitely valuable to take a closer look at the light and its interaction with the material and camera. The selection of suitable lighting is crucial in determining the image quality. It should be considered as early as possible in the planning process. No other component can compensate poor lighting. Finally, getting your vision system components from a single source can reduce both integration efforts and component costs. Thanks for watching.